Erosion is part of Earth's natural cycle and an increasing reality in some of the country's most visited beaches. Human-induced climate change has amplified the pace of rising sea levels, which magnifies the pace of erosion.
NASA has observed the Earth getting warmer and the sea level getting higher. What's the connection? Just like mercury in a thermometer, water expands when it's heated, and Earth's ocean is taking in more than 90% of the heat from global warming. That's a lot. Water temperatures also cause a lot of the ice to melt, and it ends up in the ocean. A child born today can expect the ocean to rise between 1 and 4 feet in their lifetime. In the United States alone, nearly 5 million people live within 4 feet of the local high tide level. That could mean increased flooding from storm surges. And as the ocean rises, its salt water can mix with our rivers and groundwater, which is where many people get fresh water for drinking and farming. So there's no question that sea level is rising. NASA can measure it from space, but what are we going to do about it? Some communities are taking steps to adapt, and others are working to address the cause, global warming. It's a big challenge, but hey, we'd better be up for it, because right now, good old Earth is the only planet we've got.
Daytona Beach has seen a sea level rise of a foot in the last century, but by 2100, they'll see almost 4 times that.
Today can expect the ocean to rise between 1 and 4 feet in their lifetime.
Daytona Beach has seen a sea level rise of a foot in the last century.
Today can expect the ocean to rise between 1 and 4 feet in their lifetime.
Daytona Beach has seen a sea level rise of a foot in the last century, but by 2100, they'll see almost 4 times that. So warming our planet faster is correlated directly to the sea level rise and then erosion?
Yes, sea level is controlled by both the temperature of the water, so that it is getting warmer, but also by the melting of the ice sheets and ice glaciers. And both of those contribute by putting more water into the oceans.
Okay, dump the ice cubes in here.
Okay. Whoops.
Okay, now I would like you to fill that glass with ice cubes.
Okay.
Certainly full, right?
Yeah.
In fact, sticking over the top. Okay, next, I would like you to take these 2 glasses over to the sink and fill them both almost full of water. Then bring it back, okay? Okay. Now you notice I'm wiping off the table so there's not a drop of water on it.
Okay.
And I will wipe off this plate so there's not a drop of water on it.
Why?
Well, you'll find out in just a moment, because I would like you now to use this long medicine dropper and take water from there and fill it, this glass, so that it's right to the very brim with water.
Okay.
Don't let it overflow, but get it right to the very top. Aha! That's it. Okay, move these out of the way. Wipe everything up so there's no water anyplace. Now my question is, as the ice melts, will the water overflow over the top of the glass?
I think so.
Why?
Well, because like you have the water, and the water is filled to the top, and then you have the ice also, and like I think while the ice melts, it'll just overflow.
Okay, that's one theory, and that's definitely a theory, right?
Yeah.
You know what a theory is. Well, there's another theory, which I would like to advance and see how you like that. As you know, ice expands when it freezes as compared to water. That's why ice floats, right?
Yeah.
Okay. So therefore, as the ice condenses, in other words, goes back into water, it should take up less space, therefore the water level will drop.
Okay, yeah, I see.
That's theory 2.
Yep.
Now there's the third theory. Obviously, the volume of the water is taking into consideration the ice that we've got in there. So as it melts, it's not going to change at all, because the volume has already got that ice floating in it.
Okay, I see.
That's the third theory. Which one are you going to take?
Mine. My theory.
The first one?
Yep.
That it's going to overflow.
Yeah.
Okay, now that's why I wanted to wipe up everything, so there's no water around any place. We're going to let it sit there very carefully and melt. It'll take about 2 hours. Can we be back in 2 hours?
Sure.
And I promise I won't touch it.
Okay.
Okay?
Hi.
Hi, Karen. Hi, you're right on time. 2 hours. You're very punctual. Are you usually?
Most of the time.
Okay. There's the glass that had the ice in it. Don't touch the counter now.
It didn't melt.
And your theory was that it was going to melt and flow over the top, right?
Yeah.
And why was that?
Well, the ice, like, it was floating above the top of the glass, so I thought it would melt.
Okay. That was
Go
one
over.
theory. That was no good. Now, the second theory was that the ice expanded as it would change from water to ice, therefore took up less space, so that as it melted, it would take up less space, so the water level ought to drop.
Yeah.
Did it?
No.
So the third theory, you remember now I told you that as you added water to the ice and you got it all to float, the level of the water took into effect the mass of the ice.
Yeah.
And therefore, as it melted, that water level is going to stay exactly the same. And that's what happened.
Yeah.